Hi everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics, Paper 6, which is a probability and statistics tool for May-June 2022, and the code is 9709/63. Please subscribe to my channel and stay tuned for more upcoming videos. Okay, so let's move on to question number 1. Now, question number 1. The number of characters in emails sent by a particular company is modeled by normal distribution with mean 1250 and variance is 480 squared. Find the probability that the mean number of characters in a random sample of 100 emails sent by the company is more than 1300. So from here, you are given, let's say the X is the number of characters in one email, okay? So X is normally distributed with mean 1250, variance is 480 squared. Now it's mentioned mean number in 100 emails. So you need to get the distribution of the sample mean, which is the same mean value, which is 1250, but now the variance has been changed to 480 squared over 100. Okay, and now we need to count probability that the sample mean is greater than 1300. So now, since your sample mean is normally distributed, then we will standardize it by using the formula X is normally distributed with mean mu variance sigma squared. Let's say here X bar, here over N. Okay, now my Z, if let's say without the X bar and over N, let's say I show you the original formula. Okay, your X minus mu over sigma. But if let's say you have X bar here, this is over N, that means this is going to be squared over N, then square root. Okay, so that is the sample mean distribution. Then here I will get 1300 minus 1250 over square root of 480 squared divided by 100. Right? So when you count this value, it will be Z more than 1.042. So now here we need to sketch the normal graph. 1.042 is on the right side, and this is greater than. So to get this region, it will be 1 minus PZ less than 1.042. So here 1 minus PZ less than 1.042. And the probability is 0.8513. Okay, so at last you will get 0.1487. So you can just leave it in this form, or maybe you can just round up to 3 significant figures. Alright, so 0.149. Okay, so for question number 2, Anton believes that 10% of the students at his college are left-handed. Aliyah believes that this is underestimate. She plans to carry out a hypothesis test of null hypothesis P equals to 0.1 against the alternative hypothesis P greater than 0.1, where P is the actual proportion of the students at the college that are left-handed. She chooses a random sample of 20 students from the college. She will reject the H0, the null hypothesis, if at least 5 of the students are left-handed. Explain what is meant by type 1 error in this context. Okay, what is the definition for type 1 error first? So basically, probability of type 1 error means probability of rejecting H0 if the H0 is true. Okay, so now we know that she's going to reject H0 if at least 5 of the students are left-handed. So which means now type 1 error means at least 5 means right? So here at least 5, reject H naught. Means that more than 10%. Okay, because the hypothesis testing is carried out at 10% significant level. So more than 10% of students are left-handed. When it is not true. Okay, because when H naught is true, it is 0.1. Alright, but then we reject H naught, means that it will be more than 0.1 or more than 10% when it is not true, because your H naught is true. So that's the meaning of type 1 error in this context. Now, find the probability of type 1 error in the test. So, type 1 error. So basically, for the type 1 error, I have defined it in the first part A. Reject H naught when the H naught is true. So, she's going to reject H naught when at least 5 students are left-handed. Means that X greater or equals to 5. Given that H naught is true. Okay, so when H naught is true, basically, okay, when you look at the question, 20 students in the test, okay, are chosen in the test. Then now 10% will be left-handed. That means this is binomial distributed, right? So I will write down the binomial distribution. X is binomial, N is 20, the P is 0.1. Because when H naught is true, your P is 0.1. Okay, so now when Px greater or equals to 5 means that supposedly you have to count from 5 to 20 because your N is 20, but then it's too much. Therefore, I will use the complementation rule, which means I use 1 minus all previous. So previous means Px equals to 0 until 4. Okay, and now for binomial distribution with NP, the probability of x which is binomial distributed is going to be NCX, Px, Qn minus x. Alright, then from here I will get 1 minus, so my n is 20, so 20, now when x equals to 0 means that no success. No success means all failures. I will just write, okay, so from here, my p is 0.1, my q is going to be 0.9. Q is 1 minus p. So all failures 0.9 to the power of 20. Then plus 20 C1, 1 success. Then 19 failures. Plus 20 C2, 0.1 squared, 0.9 degree 18. Plus 20 C3, 0.1 degree 3, 0.9 degree 17. Plus 20 C4, brackets 0.1 degree 4, 0.9 degree 16. Okay, then from here I will get 1 minus 0.9568. Then at last your probability is going to be 0.0432. So that is the type 1 error probability. Now see, given that the true value of P is 0.3, find the probability of type 2 error in the test. Okay, so now P type 2 error is defined as do not reject H naught, or you will say accept H1. Oh, sorry, do not reject H naught or accept H naught, right? You can say accept H naught when H naught is false. Okay, so now do not reject H naught. Look at here. When we reject H naught means at least 5. Do not reject H naught means less than 5. Okay, the x is less than 5. Now H naught is false. H naught is false means that you cannot take p equals to 0.1. That means, that's why you are given p equals to 0.3. Alright, so it is still binomial distributed with n is 20. The p is going to be 0.3 now. So less than 5, it will be just direct calculation from x equals to 0 until x equals to 4. So I will write px equals to 0 plus px equals to 1 plus px equals to 2 plus px equals to 3, and lastly it will be px equals to 4. So now in this distribution, your p is 0.3, your q is going to be 0.7. So now px equals to 0 means that no success. Then I will get all failures. 0.7 to the power of 20 plus 20c1, 0.3 power of 1, 0.7 power of 19 plus 20c2, 0.3 power 2, 0.7 power 18 plus 20c3, 0.3 power 3, 0.7 power 17 plus lastly 20c4, 0.3 power 4, then times 0.7 to the power 16. Okay, then from here I will be getting 0.238. So that's the solution of this question. Now question number 3. Batteries of type A are known to have mean life of 150 hours. It is required to test whether a new type of battery B has a shorter mean life than type A batteries. A. Give a reason for using a sample rather than the whole population in carrying out this test. Okay, so if you use whole population to carry out the test, it will be time consuming. Alright, so time consuming. So if use whole population in carrying out this test, it will be time consuming. Okay, or probably you can write it's costly or costly. Okay, so that's the reason for using sample rather than using whole population. Now, a random sample of 120 type B batteries are tested, and it's found that their mean life is 147 hours, and the unbiased estimate for the population variance is 225 hours squared. Now B, test at 2% significance level whether B batteries have a shorter mean life than type A batteries. So now, for the type A batteries, what is the mean? The mean is 150. So now you are suspecting the B has shorter mean life than A. Means that your H0 mu is 150. The H1, the mu is less than 150. Okay, and then 2% significance level, alpha equals to 0.02. Now from here, I will sketch a graph. Since it is lower tail, one tail test, based on the H1, it is less than, that means the tail is on the right side, left side. So here is going to be 0.02. Now, to get this critical value, okay, because your n is large, 120, therefore, we will be using the normal table. And then now I need this value, the positive value, so I will flip it to the right side. This is 0.02. And then I will read the table with probability 0.98. Okay, so by using the normal table, when the probability of less than, the probability is 0.98, then you will get the critical value of 2.054. but then our actual value is on the left hand side, so I will label that as negative. Okay, so from here I will write down my critical I will write down my rejection criteria, which is reject H naught if the Z is less than negative 2.054. Okay, then from here I will do the calculation. My Z is basically X bar minus mu over, now it's mentioned unbiased estimate of the population variance. So this is going to be square root of S square over N. Okay, then this is going to be X bar 147 minus this mu is the mu at the H naught, which means it's 150, over square root of the S square is given, which is the unbiased estimate of the population variance, 225, over the N is 120 because 120 type B batteries are tested. Then now when you calculate this value, it will be negative 2.19. So this negative 2.19, I will mark it on the graph, which is inside the region. Okay, therefore, I will write, since Z less than negative 2.054, then we reject H naught. That is the decision. So when reject H naught, what is the conclusion? Alright, so the conclusion is based on this, whether type B has a shorter mean life than the type A. So since we have rejected the H naught, that means it looks like we are supporting this, which means there is evidence, okay, or sufficient evidence to conclude type B battery has shorter mean life than A. So I will write, there is sufficient evidence to conclude that type B batteries have shorter mean life than type A battery. Okay, so that's the conclusion of this hypothesis testing. Now, see, calculate a 94% confidence interval for the population mean life of type B batteries. So now, 94% confidence interval for mu is X bar plus minus Z S over square root N. So now I need to know what is my Z, the critical value from the normal table. 94% means in the middle is 94, 0.94. Okay, then I know that these two parts plus together, it will be 0.06, which means now just the left hand side itself, it will be 0.06 divided by 2, which means it's going to be 0.03. Now I know that the total region towards the left hand side is going to be 0.97. So when 0.97, right, so let's say I label outside, here is 0.97. So then it will be critical value of 1.881 from the table. And then this line is going to be negative 1.881. Then now, use back the X bar that is available in previous question. So the X bar is 147, the variance is 225, and the mean is the N is 120. So here I will get 147 plus minus 1.881. Then this is going to be square root of 225 divided by 120. So now here you will be getting 144.42 and 149.58 But then since we need to give our answer correct to 3 significant figures, therefore I will round up to 144 and 150. Okay, so this is the 94% confidence interval for the mu B. Now for question number 4. Each box of seeds and raisins contains S grams of seeds and R grams of raisins. The weight of the box when empty. Okay, this is for the box. Box is B grams. So S, R, B are independent random variables where all these three are normally distributed. A full box of seeds and raisins is chosen as random. Now A, find the probability that the total weight of the box and its contents is more than 500 grams. So now we need to get the total. Let's say the total is T. T is S plus R plus B. So now I need to get the distribution of the T now. So firstly, I need to get the mean. So expected value, you just sum all together. Therefore, the first mean is 300, the second mean is 200, and the third mean is 15. Then you will get 515. For the variance, it will be variance S plus variance R plus variance B. So variance S is 45, variance R 25, variance B is 4. Then from here you will get 74. Okay, which means my T is normally distributed with mean 515 and variance 74. And now you need to get probability that the total is greater than 500. So PT greater than 500. Therefore, I will standardize it to get Z more than 500 minus 515 over square root of 74. Then here is going to be Z more than negative 1.744. Now this is sketched on the graph. So here's 0. Let's say negative 1.744 is on the left hand side. And since this is greater than, means that the region is towards the right side. This is a region for the probability. Now I need to reflect the region because the line is negative. So once I reflected it, it becomes positive. And this is going to be the region. So now I will say this probability PZ more than negative value is basically same as PZ less than positive value. Okay, once you get positive value, then you can just read from the table. The table will give you the answer of 0.9595, and then now you can round up to 0.960. So that is the probability of this part. Now part B, find the probability that the weight of seeds in the box is less than 1.4 times the weight of the raisins. So now the seeds will be normally distributed. Let me copy down the distribution first. 345. Then for the raisin, it will be mean of 200 and variance 25. Okay, now you need to count P S less than 1.4 times of the raisins. Okay, that means now you need to count S minus 1.4 R less than 0. This is the probability that you need to find, which means now I need to get the distribution for S minus 1.4 R. So S minus 1.4 R, the mean is going to be ES minus 1.4 ER. So I will get 300 minus 1.4 times 200, which is going to be 20. Now for the variance, S minus 1.4 R, it will be variance S plus 1.4 squared because it's 1.4 times. Alright, so variance R. So here is going to be 45 plus 1.4 squared multiplied with 25. Then I will get 94. So which means now my distribution for this subtraction is basically mean 20, variance 94, and both are normally distributed. So here I will write PZ less than 0 minus 20 over square root of 94. Because I'm using x is normally distributed, mean mu variance sigma squared. When you standardize it, it will be x minus mu over sigma. Okay, so now from here, when you calculate the value, it's going to be negative 2.063. So again, now I have to sketch a graph to show the region. Negative 2.063 is on the left hand side. Since it is less than, means the region is towards the left hand side. And then now I have to flip it to the right side. So when I flip, it will be 2.063 and the region becomes a red region. So in order to get the red region, it will be total probabilities of 1 minus all previous probabilities. So here I will write it is 1 minus PZ less than 2.063. And now you can just read the probability from the table and you will be getting 0.9804. Now when I minus from 1, at last you will get 0.0196. So that's the probability of this question. Okay, now next question, number 5. The number of clients who arrive at an information desk has a Poisson distribution with mean 2.2 per 5-minute period. Now A, find the probability that in a randomly chosen 15-minute period, exactly 6 clients arrive at the desk. So 2.2 per 5 minutes. So now 15 minutes means you have to times 3. Okay, 15 minutes is 3 times 5 minutes. Therefore, I will get lambda is 2.2 times 3, which is 6.6. Which means now I will say x is Poisson distributed with 6.6. Now, understood that the x is the number of clients arrive at the desk for 15 minutes period. And now you need to count exactly 6 clients. So Px equals to 6. This x, okay, since this is Poisson distributed, so you can just refer to the formula. X is Poisson with mean lambda. Probability of x equals to x is going to be e minus lambda times lambda power x over x factorial. So then from here, I will get e to the power minus 6.6 times 6.6 to the power 6 over 6 factorial. Then you'll be getting 0.156 as the final answer. Okay, now B, if more than 4 clients arrive during a 5-minute period, they cannot be served. Find the probability that during a randomly 5-minute period, not all the clients who arrive at the desk can be served. That means it will be more than 4 clients. Alright? So now I will write y, because just now I use x for 15 minutes period. So now let's y be 5 minutes period. So the mean will be 2.2. And now more than 4 clients. So Py greater than 4. So when greater than 4 means that I will write 1 minus Py less than equals to 4. So now I have to calculate 1 minus Py start from 0 until 4. Okay, then from here, again the Poisson formula, we know that x is Poisson lambda. So Px equals to x is going to be E minus lambda times lambda x over x factorial. So the E minus lambda is a constant. That means I can factorize the constant. So Py equals to 0 means you'll be getting 1 because lambda to power 0 is 1. 0 factorial is also 1. Then Py equals to 1, I will just write 2.2 because over 1 factorial is over 1. Then plus 2.2 squared over 2 factorial for Py equals to 2 plus 2.2 cube over 3 factorial plus 2.2 to the 4 over 4 factorial for the last term. Then now when you calculate all this, it will be 1 minus 0.9275. And now when I calculate the value, it will be 0.0725. So that's the solution of this question. Now for C, use a suitable approximating distribution to find the probability that during a randomly chosen 1 hour period, less than 20 clients arrive at a desk. Now, see, 1 hour has 60 minutes, right? So we know that 5 minutes, every 5 minutes you will get 2.2. So now, what I need to do here is I will write 60 minutes divided by 5. It will be 12. That means it will be 12 times of 5 minutes. So my new lambda is going to be 12 times 2.2. Okay, or probably I will just direct solve here. So now my lambda is going to be 60 over 5 times 2.2. Alright, so it will be 26.4. Now, since this lambda is greater than 15, therefore you need to approximate. So we are going to approximate to normal. This is going to be normal approximation because it is greater than 15. Alright, so now for the normal distribution, so from here I will write it is, let's say 1 hour is t. Okay, t is Poisson 26.4. Now approximate to normal. The mean is 26.4. The variance is also 26.4. Because for Poisson distribution, mean is same as variance. So now it is less than 20. Okay, within the 1 hour, less than 20 means pt less than 20. So when less than 20, be careful with this. Your Poisson is discrete random variable. The normal is continuous random variable. Therefore, we need to carry out the continuity correction. So when here less than 20, I will consider 19 or 18. Alright. And according to the continuity correction, we can plus 0.5 or minus 0.5 from 20. So when I minus 0.5 from 20, I'm getting 19.5. If I plus 0.5 from 20, I will be getting 20.5. That means now from here, obviously I will choose the interval which is less than 19.5 to include the two ticks. So I will write this is same as PW less than 19.5. And now I will standardize it. So when I standardize, I will use 19.5 minus the mean 26.4 over square root of 26.4. Okay, then from here you will be getting z less than negative 1.343. So now when I sketch a graph, negative 1.343 is on the left hand side, and since this is less than, therefore region is towards left side. Now I will flip this region. Okay, and I will label this line as 1.343. So the blue region is same as the orange region. So the orange region can be found using total probabilities 1 minus all previous probability. So now here I will write it is same as 1 minus PZ less than 1.343. And now this probability z less than 1.343 can be found using table. The table will give you this value 0.9104. So at last you will be getting the probability of 0.08 196, which is correct to 3 significant figures. Okay, so let's move on to question number 6. Now, a random sample of 5 values of the variable x is given below. 2, 3, 3, 5, 8. Find an expression in terms of a, the mean of these values. So basically, the mean, alright, equals to summation of all the terms, then divided by number of terms. So from here, I will get 13 plus a divided by 5. So that is the mean. It's very simple. Now, it's given that the unbiased estimate for the population variance of x using these values is 4. It's given that a is positive. Now, B, find and simplify a quadratic equation in terms of a, and hence find the a. Okay, now the formula for the unbiased estimate of variance, it will be x squared equals to 1 over n minus 1 summation x squared minus summation x bracket squared over n. Okay, so now x squared is given 4. So now since your n is 5, so n minus 1 becomes 4. So 1 over 4. Summation x squared, just square all of the terms. So I'll get 2 squared plus 3 squared plus 3 squared plus 5 squared plus a squared. So here I will just list down 2 squared plus 3 squared plus 3 squared plus 5 squared plus a squared. That is my summation x squared minus, okay, summation x. So look at here, summation x I already found. This is my summation x, which is 13 plus a. Then I will write 13 plus a squared over 5 because the n is 5. Okay, then from here I will times the whole equation by 4. Or probably I will just move up this 4. So it will be 16. Okay, so 16 equals to, now you count, what is the total of this sum? It will be 47. Then plus a squared, then minus, okay, now because we need to get quadratic equation, which means we must expand this quadratic. So you can expand it using a plus b squared equals to a squared plus 2ab plus b squared. So now you square the 13, okay, or probably I can factorize the over 5 first, becomes 1 over 5. So I square the 13, it will be 169. Then plus, second term is going to be 2ab. So means 13 times a times 2, it will be 26a. Lastly, a squared. Okay, then now we need to simplify this to get a quadratic and make sure it is the simplest form. So from here, the easiest way is to times the whole equation by 5 because I want to eliminate the over 5 there. So I times the whole equation by 5, then you will get 80 for the left hand side. 47 times 5 is 235. Then a squared times 5 is 5a squared. After that, this minus just bring into all the terms inside the bracket. You will get negative 169 minus 26a minus a squared. Okay, then now I will simplify. 5a squared minus a squared, it will be 4a squared. Then I only have one a, negative 26a. Right, then this 80 move to the left hand side and combine with these two constants. So at last you will be getting negative 14. Then equals to 0. So now to get the simplified quadratic equation, I have to divide the whole equation by 2. Which means 2a squared minus 13a minus 7 equals to 0. So this is the quadratic equation. Okay, done for the first part. Now, and hence means use the quadratic equation that you have found to get the a value. So now we need to solve this quadratic equation. So this quadratic equation can be factorized into two linear factors. The first is a minus 7, and the second is 2a plus 1. Then from here, a minus 7 equals to 0 means a equals to 7, or 2a plus 1 equals to 0 means your a is negative half. But then when you look at the question, right, it's mentioned that the a is positive. So a is greater than 0, therefore the a is going to be 7. So that is the solution for second part of this question. Okay, now for question number 7. The random variables x and w have probability density function f and g defined as follows. Fx and gw. Okay, write down the value of px at least 0. So we know that from the fx, when the x is greater equals to 0 and less equals to a, this is the probability. So when it is greater equals to 0 means that you define, okay, you integrate. Probability is basically integration. So probability x greater equals to 0 means you integrate 0 to a fx dx. So this, since the fx is the probability density function, that means when you integrate the function throughout the whole interval, the probability is going to be 1. That's the definition of probability density function. That's why the question just asks you to write down the value without any calculation. Okay, so now part 2 writes down the value of PW at least 0. So now PW at least 0. Let's look at the question now. So from here, your W is defined from minus A to A, which means, let's say this is your minus A to A. This is the W. Okay, and when you look at this graph, this is a quadratic curve. Your W is the variable, right? It's like the X. So now when you sketch this graph, right? So now here, I will just explain over here. When you sketch this quadratic curve, your y-axis is GW, your x-axis is W. So when I let my GW be 0, okay, so I will get q bracket a squared minus w squared equals to 0. Then this one is going to be q bracket a minus w, a plus w equals to 0. Then now I know that my w is going to be a and minus a because you let these two be 0. So it means that my graph is going to be like this, and then it will be symmetrical because it is a quadratic, symmetrical at the middle. So the middle definitely is 0, right? Something like this. It's symmetrical. Alright, so now from here, obviously, right, this is my graph. So obviously, okay, the probability from minus a to 0, it will be half of the whole graph, isn't it? Right? So this is the explanation for the part 2. Okay, then I will just write equals to 0.5. So this is the A part 2 explanation. Okay, so now part 3 writes down an expression for Q in terms of P only. Okay, so what to do here is I need to get the expression for P and Q. So now I need to sketch a graph. Okay, so for P, let's see. Fx is P bracket a squared minus x squared. So Fx is P bracket a squared minus x squared. Then the x from 0 to a. Okay, so now I have to sketch this graph. Again, this is a quadratic curve. This graph is similar to this graph, okay, in the same shape. That means now I'm sketching it. It's supposedly like this. But then now my graph is just defined from 0 to a, which means I will be getting this part only. And here is my a. Here is my 0. Okay, so I have to erase the blue line, the blue curve. So this is my fx. Here is my x. Now, when I redraw my G graph, okay, GW. So this is my GW. Here is A, here is minus A. My GW is basically Q bracket A squared minus W squared. This is my W, this is my GW. Then the W defined from minus A to A. Okay, now from here, I know that I need to find this value. Right, so for the fx, at this point, the x equals to 0. So when the x equals to 0, right, look at here. When this equals to 0, that means it will be PA squared. So I will label my intersection with PA squared. Okay, let me write properly. This is going to be PA squared, this point. Now, same for the GW. So if at this point, right, which means at this point, the W equals to 0. So if I let this be 0, I'm getting QA squared. So which means this point is going to be QA squared. Alright? And then from here, I know that 2 times, okay, 2 of the probability from W, the W from 0 to A is same as P0 to A. Because the probability here is going to be 1. The total of probability here is going to be 1. That means, right, when you look at the W graph, I will just consider 0 to A. So 0 to A is half of the original, which means I will say double of the orange line will be 1. Right? Will be same as the Px less equals to between 0 and A. So due to that reason, I will just write this is 2 probability of W between 0 and A. W between 0 and A, when you look at here, right, this probability is QA squared. Then the probability of X between 0 and A, when you integrate, right, is going to be PA squared. Then from here, I will just say the A squared can be cancelled off. Then I will be getting 2Q equals to P. But then the question asks for Q in terms of P. So it means that now I have to move my 2 to the other side. Therefore, my Q is going to be P over 2. Okay, so this is how we get this solution. Now, B. Given that expected X is 3, find the value of A. So now, expected X is integration of X. Let me see. Where is the X first? X fx. Okay, GW. So fx. So now, X fx dx. And then the X is defined from 0 to A. Now, you need to find what is the A. So basically from here, Ex is 3. So now you integrate from 0 to A, X, the Fx, right, the Fx is P of A squared minus X squared. So P of A squared minus X squared. This is my Fx, then dx. So now here, I need to know what is my P, because you need to find A. I cannot have P here. So now I need to find the P, but we know that the P is basically 2Q. Okay, that means now I need to find what is my Q. So now my Q can be found using the GW. So we know that the total properties is going to be 1. Then from there, we are able to find the Q. Okay, so I need to find Q first. Then only I can get the P. So I will continue here. So now, what is the Q? Okay, then I will integrate from minus a to a, GW dW is 1 in order to get the Q. So now, when you look at the GW, it will be Q times a squared minus W squared, whereby the W defined from minus a to a. So now, since the Q is a constant, I will take out the Q, then I integrate from minus a to a squared minus W squared dW is 1. Okay, now, remember your W is a variable, A is a constant because you need to find A. So now, integrate this, you will be getting a squared W minus W cubed over 3. Limits will be from minus a to a, then equals to 1. Okay, then now I have to replace the W by a. So I will get Q bracket a squared times a minus a cubed over 3, then minus when the a is minus a, when the W is minus a. So a square bracket minus a minus a cubed over 3. That equals to 1. So from here I will get Q bracket. The first one is going to be a cubed minus a cubed over 3. Then minus, now a squared times minus a is going to be negative a squared, a cubed, sorry, minus a cubed. Then the minus a cubed here is going to be minus negative a cubed. Then minus minus is a plus. So plus a cubed over 3. Then here equals to 1. So when you open the bracket, basically a cubed minus a cubed over 3. Minus minus is a plus, a cubed. Then minus plus is a minus. So now, when you simplify, 1a cubed plus 1a cubed is 2a cubed. Then minus this 2 means that minus 2 over 3. So 2 minus 2 over 3, you will be getting 4 over 3. A cubed equals to 1. Then from here, I will be getting my Q. My Q is basically 3 over 4a cubed. Okay, and now I need to get the P. So from the previous part, the P is 2Q. So now I will get my P here. So my P is 2Q. This is from previous part. Previous part is part 3. So here I will write from part 3. My P is 2Q. Therefore, it's going to be 2 times 3 over 4a cubed, which means you are getting the 2 and 4 can be simplified. So you will be getting 3 over 2a cubed. So that is the P. Okay, so now I'm going to substitute this P in my integration. So now it will be 0 to a x. So your P is 3 over 2a cubed. So 3 over 2a cubed. Then a squared minus x squared dx. So since the 3 over 2a cubed is a constant, I can just take it out. So it will be 3 over 2a cubed, integrate 0 to a, and then now this x will be times to the bracket. Then I will be getting a square x minus x cubed dx. And now I will do the integration. Your variable is the x, your a is a constant. So when you integrate a square x, it will be a square, the x change to x squared over 2, minus x degree 3 becomes x degree 4 over 4. Then limits will be 0 to a. Now here is going to be 3 over 2a cubed, right? Then now you replace the ax by a. So I will get a square times a square over 2, right? Therefore you get a degree 4 over 2. Minus, replace the x by a, you will get a degree 4 over 4. Then minus, when the x by 0, so it will be 0 for all the terms. Then now I will get 3 over 2a cubed. Now 1/2 a4 minus 1/4 a4, it will be 1/4 a4, right? A degree 4. So from here I will further simplify. The a cubed and a degree 4 can be cancelled off. Then you will be getting 3 over 8a, and all this equals to 3. Then now to get the a, I will just move the 3 over 8 to the left side. So now my a becomes 3 times 8 over 3. Therefore, you will be getting the a as 8. So that's the solution of this question. Okay. Alright, so we have come to the end of the video. Thanks for watching. Please subscribe to the channel and share it to your friends. And also stay tuned for more upcoming videos. Alright, thank you. Bye.